Welcome to Bean Energy. Today I'm going to be working on some SPIM08HP cells. Such a mouthful. Anyway, it's just these pouch cells here that you can get from a couple places. I know that batteryhookup.com has them, Battery Clearinghouse has them. They are 8 amp hour cells at 3.7 volt nominal, 2.5 volts to 4.2 volts, and they are high amp draw cells. So these are supposed to be able to do 200 amps continuously, which leaves lots of room for error. I'm going to be hooking them up to a 40 amp 13S BMS. I'm going to do an 13S 2P. This should net me about a 750 watt hour pack. Looks like this guy has got some 10 gauge wire coming off of it. So I have some 10 gauge wire to pair it with. I've got some Kapton tape, some fasteners, some pass-through connectors, and some other tools, multimeters. I'm going to put them inside of this ammo box. This is a Fat 50 ammo box. So we'll find out if I am successful or how badly I fail. All right, so my first step is going to be grabbing all of my cells here and see if I can sort them out in a way that makes sense. So I know these are testing anywhere from high 7s to high 8s in amp hour capacity. And what I did is I used one of these SkyMax B6 AC devices to cycle each of the cells. So let's get these sorted. So there's an 8.3, 8.9, 8.8, 8.3. That's a 6.9. I may not use that one. Yeah, that was scary. You found the light. Say hi to the camera. Hi. Can you say hi? So what I could probably do is take all of my 7s and pair them with my high 8s. And that would give me a pretty good distribution. 8.5, 7.8. Looks like most of these are right around the 8 amp hour mark, which makes a lot of sense. All right, so now I can just grab off that stack, top to bottom. And what I was going for was, if these two are in parallel, you got 8.3 plus 8.3 is 16.6 amp hour capacity, where if I have one down here that's like 7.9 plus 8.6, it's gonna be pretty close. All right, so now let's go ahead and grab a couple of cells, and I want to show you what I'm going for here. So I'm gonna put these terminals here on the back, and I'll have wires poking through. I'm actually gonna do like here and here. Wires poking through going to a XT60 connector, which I don't have out here, but I'll grab those. That gives me a waterproof connection, which really I'm not that worried about because I'm going to end up putting a vent hole in here anyway for these lithium ion cells to exist inside of a metal container. But it does give me something where the wires will not be rubbing on the metal. So inside of here, I'm going to put the cells up and down, and there should be just enough space for those to stack. I should not fill all the space end to end, but it'll be pretty close. I will have space though on the sides here, so that's where I can put my BMS and run wires and whatnot for the batteries. Anyway, that's what we're going for. Now if my BMS is going to be here at the back, and I've got my negative cables for charging and for power here at the back, then I really would like to not have to extend this. I'd like to connect this straight to the battery. Planning on putting this down here on the inside, and I want the negative end of the pack to be on this end, which I suppose doesn't really matter because when I put it all together, I'll have a negative and a positive, and I can choose which one goes where. So let's start with negative end. So I'm going to expose the positive terminal for these two cells. You'll see that these holes can line up fairly well. But what we're going to do is, instead of having these slots that the screws can kind of fall out of, I'm going to go ahead and punch a new one out in the middle so that we can get everything lined up a little bit better. All right, so let's get these clamps together so they're a little easier to work with. All right, so that's how they're gonna bolt together. Now, one thing I do need to do is go ahead and get my BMS wiring going. What I think I'm gonna do is go ahead and strip these out a little bit more, make them into rings, and then solder them. And then I'll be able to stick them under each of the screw terminals. So let's get these stripped and ready to go. Alright, so that's about what we want. I can loosen that up just a tad for once I get the solder on there. So let me do a test solder on this guy. Make sure it works the way I want it to. Alright, now I got all our BMS connections. What I'm also going to do is unplug it so I'm not applying any power to the BMS itself. Alright, so the way this is wired up, this is going to go to our main negative that I was talking about earlier. And I do believe I started on the negative end here. So if this is the main negative, then this is going to be my first positive connection, which is the one that I just made. Nice and tight connection there. We get to move on to the next. So I think what I'm going to do is I will Kapton this up. Let's rip these positive terminals off. It might have been easier before I taped it up, huh? Now we find out if this can actually fit in here. Nice hole punch right through the middle there. Alright, our next positive wire, and just screw in a bolt. Something I should be checking as I go here is that each of these cells is still at 3.7 volts. I didn't check the whole batch. These were all cycled amp hour capacities measured and recorded, and then I've let them sit for a couple of months. So it's kind of a good test of will they hold a charge. They have that self-discharge problem. But in order to find out that, I need to actually measure the voltage. So far all of these are good. We are nearing the end, at least of the electrical pieces. So I am bolting on the main negative for the pack. We've already got the main positive, and I don't know how long that cord needs to be, so it's still connected to the spool. For some reason, I thought that this was going to be pretty tight in that ammo box, but there's actually quite a bit of space left once I've gotten it all together. These two are going to leave the case, so I'm going to have this on the side of the ammo box, and those two will leave the case. So I need to know, this guy's going to fit right here. So let's manage these cords a bit. Actually, you know what? Something I like to do before I plug this into the BMS is verify that these are all correct. So I want to take my main negative, put my multimeter on it, and then probe out each of these in sequence and make sure that the voltage goes up by about 3.7 every single time. So let's do that real quick. That way I don't accidentally plug in my BMS here in a minute and short something out. All right. Multimeter on DC volts. I'm gonna go negative here. We're not gonna short anything. 3.7, 3.74, then 10 something, 11.2, 14.9, 18.5, 22.2, 26, 29, 33. Don't mind the beeping, that's just a high voltage alarm on my multimeter. Oh, totally forgot what we said. 33, 37, 40, 44 and a half, 48 and a half. Yeah, last one's got a little more voltage in it. We'll see how well the balancing works. Now we've got all of this, and I want it to come to about there. So now we're gonna drill some holes in the side of my ammo case here, which will fit my waterproof wire connectors. So we're going to have the positive and the negative from the battery coming out of here. I looked on the inside and I think that this is about where I want it. That is the dullest drill bit of all time. Get a red one. Alright, so what we're going to do now is connect my charge wire that I didn't connect before. Forgot that I only had a BMS that does separate port for charge and discharge. So instead of piggybacking off of my discharge wire, I'm just going to go run a new wire for my discharge. I'm just going to put this on its own terminal. So as I'm connecting my charge cord here, some thoughts that I had. If I was to do it again, I'd get a common port BMS instead of having the charge and the discharge separate. Especially now that I've got a way of charging things over solar instead of this little 1.5 amp power supply.
I'm going to do quiet time.
Okay. Looks like it's charging. When I unplug, it drops just a tad. It's only a 1.5 amp charger, so makes sense that it's charging very slow. Well, there we have it, people. We have a battery. Should we go find out if it works? All right, so I figured out a good test we can use. I've got this setup here that normally has its own 48 volt battery running through this 48 volt inverter, and been mainly using to run this air conditioner in the background. That one there. It's just a little 5,000 BTU unit. So this is really only gonna be about a 10 amp draw. There'll be a bit of surge in there, but let's go ahead and run this and we'll get something out of it, right? Plug into our discharge port here. Ooh. Turn our inverter on. No? Nothing. Grab a multimeter. See what we're reading. I wonder if I have to reset the BMS after shocking it like that. I may have exceeded its surge current. All right, let's see what this is reading on the charge port, since that's easily accessible. I guess I can access it here. Let's go. I'm gonna say there's nothing here though, because yeah, the charge controller's dead, which that would be reading something if I had voltage. So let's try applying some energy into the battery. Maybe that'll reset the BMS. Does not appear to have reset anything. And the charger is not charging. I'm getting 48 volts now. Oh, and now it's charging. So maybe it wanted me to disconnect the load. All right, so now the question is, why did it spark? Was it just the charging of the inverter? It's probably the case. Let me try it again. Okay, I really shouldn't do that again, but we're on. Let's unplug the charger. We've got battery voltage here, 48.4 volts. Let's turn on the inverter. The AC is kicking on. It's set to 70 degrees. Go ahead and turn that down. Alright, so it's set to 64. So we're seeing 1.3, 1.4 amps coming out of the battery. That's about right. What was that, about 60, 70 watts? This is the voltage of the battery here. So we're at 48.2 volts. When the compressor kicks on, we should kick up into the 10 amp range. There we have it. Compressor running. Voltage drop wasn't too bad. We're at 7.8 amps. These batteries were right around nominal voltage, which is why we're sitting at around about 48 volts, since that's the nominal voltage of a 13S lithium ion pack. So I guess the next thing is I need to capacity test this tomorrow. So I'll plug it in and charge it overnight, and we'll find out what happens tomorrow. All right, so here we are the next day. I've got the battery fully charged. Now I went through and tested at the BMS connector, and most of the cell pairs are at 3.8 volts or so. One of them is at 4.2 volts. So not what we wanted, because we wanted it to balance charge, not just cut off when it reached 4.2. There is a plus though, it cut off when it reached 4.2. Another BMS that I had cut off at 4.28. I'm much more comfortable with it cutting off at 4.2 than almost 4.3. I was reading around and somebody suggested cycling the battery up and down a few times and that it should balance. So maybe once it cuts off the current that's coming in from the charger, it can no longer give any more to the cells that are lower. And so it's only able to do as much as the individual resistors allow it to while it's doing the charging. So I'm gonna go ahead and run this battery pack down. I've got it connected up instead of my BMW battery in this solar generator. And we're gonna run the AC and this box fan filter for a few hours tonight and see if I can deplete it enough that I can then charge it back up overnight. So the BMS should cut off when the voltage reaches low enough on these cells, which probably shouldn't be too long considering they're only at about 3.85 volts a piece. Now I'm sure it doesn't bottom balance. That would be a advanced feature on a BMS, but hopefully it's going to top balance. So the idea here is that if I discharge this, put it back on the charger tonight, then when I come grab it tomorrow, that the cells that were at 3.85 are more in the 4 volt range, and maybe I have to do it a few times to get things to balance out. The reason that it was unbalanced is I put one cell in there that was still charged to 4 volts, and the rest of them were 3.6, 3.7 volts. So really I'm okay with this. This kind of adds to the testing of the BMS itself, and whether it actually balance charges. We've got the AC kicked on, so we're pulling 10 amps here. So we will do that for a little while. This is a 16 amp hour pack because these two cells were 8 amps a piece. So that should only take me, I bet you, an hour and a half at this rate to deplete the pack. So I'm gonna go ahead and set the AC temperature nice and low so that it continues. Actually, I can also turn this fan up. That gives me almost 11 amps. So I'll go ahead and set the AC temperature nice and low so that that continues to run this evening. And we'll come back when it is discharged and find out what the lowest cell voltage is on this BMS. All right, so we ran it. It actually only ran for half an hour or so before we hit low voltage cutoff. So I'm gonna pull this BMS connector out and we're gonna see what the lowest cell is reading, and then we'll put it back on the charger. All right, so that's the lowest cell is 315, which is a little disheartening because that's a lot less than the 3.5 volts that a lot of them are at. So it probably cut off at 3 volts. So we will get this all charged back up and plug the BMS back in. That would be important. It is doing its job, making sure that my unbalanced pack here doesn't overcharge. This does tell me that if I was going to do this again, I would make sure that my batteries were balanced a lot closer before I put it together. I wasn't sure what would happen. And if I had an active balancer, it wouldn't be such a big deal. But with this semi-passive one, it takes a little more time. All right, put it back in the charger. All right, here we are. It's the next day. I charged it up again last night, and there was a negligible difference in the drift between the high cell and the rest of them. The BMS that I've got has a top balancing feature. So as it's charging, if you assume 4.2 volts is full, when it hits 4.18 volts, it will start balancing. So when this last cell pair reaches 4.18, the BMS will start bleeding off some of the current. Problem is, it only does it at 30 milliamps, plus or minus 5 milliamps. And if you calculate that out, when you've got a 16 amp hour capacity on each of these cells, that could take a really long time. Even with my charger that's only charging at about 1 amp, that could take a lot of cycles. And I was wondering if the BMS just wasn't working at all. I was reading online and people were like, well, just cycle the battery a few times. I didn't actually do the calculations, but I think it could take possibly dozens or hundreds of cycles in order to get them to balance out. I'm gonna go ahead and buy a balancing board, an active balancer, because you can plug it into the leads for the BMS and it'll actively go in and bleed off voltage from the higher batteries, the higher cells, to bring everything back down to equalization. For right now, what I'm doing is I've hooked up one of my B6 AC RC chargers to just the one cell at the end here. I've actually got 2 of them hooked up, so they're bleeding off at about 2 amps while I am charging the whole pack. So we can see here that the voltage of this last cell is at 4.15, and if I look at the voltage of the next cell, it's 4.04. So we're getting close. We're only about 1/10 of a volt off, and that will allow me to be close enough in capacity that I can get some power out of the battery. And then as I cycle it, charge and use and charge and use, it should bring everything back into balance. Now, if one of these cells or more than one of these cells are weak and self-discharge, this BMS wouldn't have a lot of capacity to be able to bring it back every time you charge, because it's such a big battery pack for the 30 milliamp balancing rate. So if you've got cells that are recycled like these and they don't like to stay in balance, then you're gonna need a better BMS, possibly with an active balancer that can keep them all in sync easier. But we'll see how this works out. It actually looks like it has tapered off its charging. So I'll go ahead and check around on some voltages here and see how it's looking. Maybe do a discharge on it and see if I've got a lot more capacity now. All right, so first of all, confessions. I bought one of these balancing boards, and it's a pretty inexpensive board on Amazon. It was $35. It will do 13S. And right here on the board itself, it shows which one is B- and which one is B13. But the connector, I believe that's a JST type connector, is the same as my BMS. I thought, well, I'll just plug my BMS connector into the balancer board. And it even went through my mind, well, the B- is opposite, but I mean, it's a balancing board. It should be the same, right? It fried the balancing board. So anyway, this is balancing board 2, and I've got it plugged in now. And you'll see these little LEDs flashing on and off, and they're labeled. Like the first one is labeled 1-2 or 122, I don't know. And then 2 to 3, 3 to 4, 4 to 5. So you'll see that like 5 to 6 is currently on, so it's balancing cell 5 into cell 6. This is supposed to do like 1.2 amps worth of balancing. I don't know if that's throughout the whole board, like if all of them were having to be balanced at once or if that's individual. But if we count my B- being cell 1, we've got 2, 3, 4, 5. So it should be balancing from cell 5 here over to cell 6. So if we measure the current on this wire right here, I realize it's gonna be upside down for you guys. We're getting 0.34 amps. And I realize a clamp meter isn't the most accurate thing in the world, but in reference, if we measure this one here, we're reading 0.08. So definitely more current flowing through that one. So that's pretty cool. The balancing board seems to be working. And yes, I've just got these wires stuck into the cells because it's just temporary. My Dally BMS should be able to handle the balancing long term, but this will help me get them all in sync here at the beginning. The last test that I ran after manually balancing some of the cells was I got 550 watt hours at the AC side, running my air conditioner before I hit low voltage cutoff on the battery itself. So after letting these balance, I'll charge them back up, and then I'll run it again and see how much capacity I gain. I don't think that the cells were too far off, so I might get maybe 600 watt hours on the AC side, which would be about right because it's supposed to be a 750 watt hour pack. So being that they're used cells, I think that would be about right. No, please don't touch that, Rose. Well, we've come to the end of testing this battery now that we've built it. After doing my active balancing, I was able to get 596 watt hours on the AC side. So if we assume a 10% efficiency loss in the inverter, that's about 650, 660 watt hours. Should have been about 750 according to the 29 watt hours a piece on these cells. Now this BMS only goes down to 3 volts for a cell, and the full capacity on these cells is down to 2.5 volts. So that's about right. I feel like it's a pretty satisfying build. I've now got a 600 watt hour battery pack that I can use, and I can replicate that across multiple. I feel pretty safe that it's in an ammo box. It's not completely sealed, so if one of the cells does decide to fail and vent, it has a place to vent, but it's not going to catch fire and catch something else on fire. I feel like the ammo box would probably contain that. So I'm pretty happy with it, and it's got a handle. I've got a XT60 connector that I can connect various devices to. So yeah, let me know what you think. There's so many different ways to build batteries, so many different cells to use. These are very high amperage cells, so I could definitely have gone through and done this with bigger connectors, bigger BMS, and been a higher amperage draw device. So let me know what you're working on, what battery you're building, and what project it's for. There's so many fun things out there, and I will see you next time here on Bean Energy.